From the moment we wake up to the instant our eyes close at night, our lives are a collection of repeated actions. These repetitions, seemingly small and inconsequential at first, quietly sculpt the way we move, think, and respond to the world around us. Picture a river carving a canyon over millennia, each drop of water wearing away stone imperceptibly yet inexorably. In much the same way, the repeated actions we take shape the neural architecture of our brains, transforming simple routines into enduring habits. At the heart of this process is the brain itself, a complex organ that thrives on efficiency. Every decision, every motion, every thought carries a metabolic cost. Conscious attention demands energy, focus, and resources. Our brains, ever economical, seek shortcuts. The repeated actions we perform allow the brain to conserve energy by automating behavior. It learns to recognize patterns, to predict outcomes, and to execute sequences with ever-decreasing conscious effort. Consider the act of walking. For a child, the first steps are a study in concentration, balance, and uncertainty. Muscles tremble with exertion, minds focus intensely on every small shift in weight. Yet, with practice, walking becomes second nature, almost instinctive. The repetition strengthens neural connections, and pathways that once required conscious direction now operate seamlessly in the background. This principle applies not only to physical movements, but also to mental and emotional behaviors. Repetition trains the brain to anticipate and respond, turning fledgling behaviors into habits that become deeply ingrained over time. The human brain has a remarkable capacity for what scientists call neuroplasticity, the ability to reorganize itself in response to experience. Every action taken repeatedly strengthens connections between neurons, forming what can be described as neural highways. The more frequently a route is traveled, the smoother and faster the journey becomes. Initial efforts to establish a new habit may be slow and cumbersome, but with repetition, the brain rewires itself to perform the task with minimal conscious effort. This is why learning any skill, from playing an instrument to practicing a language, relies so heavily on consistent practice. Each repetition is a thread in the tapestry of habit, gradually weaving patterns that define behavior. Repetition does more than create efficiency. It also creates familiarity and comfort. Humans are creatures of habit in part because predictability reduces stress and uncertainty. When an action is repeated enough times, the brain begins to recognize it as routine, diminishing the mental friction that comes with unfamiliarity. The simple act of making coffee in the morning or checking a phone notification becomes a source of comfort because the repeated pattern signals predictability and control. In this sense, habits are not just mechanical. They are psychological anchors in a world full of unpredictable stimuli. The ritual of repetition reassures the mind, providing stability and a sense of order. From a behavioral perspective, repetition serves as the foundation upon which reinforcement builds. Every repeated action carries with it feedback, whether in the form of success, satisfaction, or avoidance of failure. Positive reinforcement strengthens the likelihood that the action will occur again. Even subtle rewards, such as the pleasure of a correctly solved puzzle or the sense of relief from completing a task, reinforce the repeated behavior. Over time, these feedback loops become self-sustaining. The brain begins to associate the action with positive outcomes, making it more likely to continue the behavior without conscious deliberation. It is a quiet, almost invisible process, yet it underlies the formation of nearly every habit we observe in ourselves and others. Repetition also interacts with memory in profound ways. Each time an action is repeated, the memory of performing that action is reinforced. This is particularly evident in motor skills, where repeated practice strengthens procedural memory, the kind of memory that allows someone to ride a bike or type on a keyboard without actively thinking about each movement. Unlike declarative memory, which requires conscious recall, procedural memory thrives on repetition. Once established, these repeated actions are recalled automatically, a process that further cements them as habitual behavior. The brain's capacity to embed repeated behaviors into memory ensures that habits persist even in the absence of conscious attention. Yet, repetition alone is not sufficient. Context matters. Habits are formed most effectively when repeated in a consistent environment or under specific conditions. A behavior repeated at random or sporadically is less likely to solidify into a habit because the brain struggles to establish a predictable pattern. It is the combination of repetition and context that allows the brain to anticipate and execute the behavior efficiently. Over time, the presence of familiar cues triggers the habitual response automatically. In this way, repetition acts as both the architect and the construction crew, while the surrounding environment provides scaffolding for the emerging habit. The process of repetition also highlights the interplay between conscious effort and unconscious execution. In the early stages of adopting a new behavior, conscious attention is paramount. Every step is deliberate, every action monitored and corrected. But with repeated performance, the conscious mind gradually releases its grip. The behavior migrates into unconscious processing, where it can occur without deliberate thought. This transition from conscious effort to automaticity is the hallmark of habit formation. Repetition is the mechanism through which control is transferred from the demanding, energy-intensive conscious mind to the efficient, effortless unconscious mind. In addition to shaping behavior, repetition molds identity. The actions we perform consistently become part of our self-concept. Someone who writes daily, exercises regularly, or meditates every morning internalizes these repeated behaviors as defining elements of who they are. Repetition is not just about efficiency, it is about becoming. Every repeated action reinforces a narrative about the self, subtly signaling to the brain, "This is who I am, this is what I do." Over time, these habitual actions integrate so thoroughly that they feel inseparable from our identity, further embedding themselves into daily life. Repetition also plays a role in emotional regulation. Habits formed through repeated actions provide predictable pathways for managing stress, anxiety, and other emotional states. Rituals such as deep breathing, journaling, or running are repeated behaviors that offer emotional stability. The brain learns to associate these repeated actions with calm and relief, making them preferred responses in moments of emotional turbulence. Here, repetition serves not only to streamline behavior, but also to cultivate emotional resilience. Finally, the cumulative effect of repetition underscores the subtle yet transformative power of small, consistent actions. While dramatic efforts may capture attention, it is the quiet, repeated behaviors that ultimately shape who we are. Each repetition leaves a trace, each iteration builds upon the last, until what was once deliberate becomes automatic, and what was once effortful becomes instinctive. In the end, the story of habits is a story of repetition, a story of persistence, of small choices compounded over time, sculpting our brains, our behaviors, and our lives with patient, unrelenting force. As repetition continues to shape our lives, the subtle ways it influences thought, behavior, and even perception become increasingly profound. Over time, repeated actions are no longer isolated events. They merge into a seamless continuum, forming patterns that guide the way we navigate the world. What once required focus now unfolds effortlessly, and the mind learns to rely on these patterns as trusted strategies for managing complexity. This is why habits feel automatic. They are not merely behaviors repeated enough times, but carefully reinforced pathways the brain has grown to depend on. Scientific research has revealed how deeply repetition imprints itself on the brain's structure. Each time an action is performed, neurons communicate through synapses, sending chemical and electrical signals. With every repetition, these synapses strengthen, forming robust connections that make future signaling faster and more reliable. The process, often described as neurons that wire together, highlights the profound adaptability of the brain. Repetition does not just create temporary change. It physically alters the architecture of the mind, laying the groundwork for behaviors that can endure a lifetime. The importance of consistency cannot be overstated. Irregular practice or sporadic effort rarely produces the same effects as disciplined, repeated action. Inconsistent repetition leaves neural pathways fragile, preventing habits from solidifying into automatic behavior. On the other hand, steady, repeated action allows the brain to anticipate patterns, integrate sequences into procedural memory, and eventually execute them without conscious guidance. This explains why expert performance, whether in sports, music, or writing, requires not only talent but persistent, focused repetition. Mastery emerges not in a single moment of brilliance, but in thousands of small actions repeated over time. Repetition also interacts with reward systems in fascinating ways. Each repeated action that produces a positive outcome triggers the release of dopamine, a neurotransmitter associated with pleasure and motivation. Dopamine not only makes the action enjoyable, but reinforces the neural pathways that support it. Over time, this creates a feedback loop. Repeated action strengthens the brain's structure, reward strengthens motivation, and motivation encourages further repetition. Habits, in essence, are both the product and the reward of repeated effort. Even seemingly mundane actions, when repeated and reinforced, can become enduring behaviors that shape daily life. Context remains a critical element in transforming repetition into habit. Environmental cues, social structures, and timing all contribute to the likelihood that a repeated behavior will persist. A person who exercises each morning in the same location, at the same time, leverages context to cue the action automatically. Similarly, routines tied to specific environments, objects, or times of day create a predictable framework that the brain can rely upon. Repetition alone is necessary but insufficient. It is the interplay of repetition and context that allows habits to take root and flourish. Repetition is not solely about physical actions. It profoundly shapes mental and emotional habits. Repeated patterns of thought, reflection, and emotional response gradually embed themselves in the brain, influencing decision making, perception, and world view. For example, a person who practices gratitude daily may begin to naturally perceive opportunities and experiences through a lens of appreciation. Similarly, repeated reflection or journaling can strengthen analytical thinking, emotional intelligence, and problem-solving ability. Habits are therefore not confined to the body. They extend into cognition, shaping the mind itself. The role of repetition in emotional resilience is particularly noteworthy. Consistent routines, rituals, and coping strategies provide stability in the face of uncertainty and stress. By performing the same action repeatedly, whether it is meditation, deep breathing, or exercise, the brain learns to associate these behaviors with calm and regulation. Over time, repeated actions create neural patterns that help the individual respond automatically to emotional challenges, reducing the cognitive load and stress associated with novel or unpredictable circumstances. Repetition, in this sense, is a form of mental training as much as it is behavioral. An equally important consequence of repetition is the formation of identity. The behaviors we choose to repeat become markers of who we are. Writing daily, volunteering consistently, practicing a craft. These repeated actions accumulate into a sense of self. The brain interprets patterns of repetition as signals of identity, reinforcing self-perception and influencing future choices. Repetition shapes not only what we do, but who we believe ourselves to be. Habits become inseparable from identity because repeated behavior convinces the brain that the action is normal, natural, and reflective of the self. Over longer periods, repetition transforms into instinct. Actions that began as deliberate choices gradually migrate to unconscious execution, requiring minimal attention or effort. This is the culmination of habit formation. Behaviors that once demanded focus become instinctive, almost reflexive, guiding life with remarkable efficiency. Driving a car, navigating a familiar route, or performing a complex skill without conscious thought are all examples of repeated behaviors elevated into instinct. The journey from action to habit to instinct underscores the power of repeated effort. It is the invisible architect of the mind, silently shaping the contours of everyday life. Even in the realm of learning and education, repetition proves indispensable. Mastery of language, mathematics, music, and countless other skills relies on repetition. Students who review material repeatedly, musicians who practice scales diligently, athletes who train consistently. These individuals leverage repetition to convert knowledge into action, turning conscious effort into automatic skill. The effectiveness of repetition is universal. It is as essential for mental processes as it is for physical performance. Without it, even natural talent struggles to manifest as mastery. The cumulative effect of repeated actions also extends to societal and cultural levels. Collective habits, built through repeated behaviors over time, define norms, rituals, and traditions. Cultural practices, from daily greetings to religious ceremonies, persist because repeated participation reinforces their structure and meaning. Just as individual habits shape personal identity, collective repetition shapes communal identity, demonstrating that repetition's influence is both intimate and expansive. Yet repetition is not inherently positive. Habits, once formed, are resistant to change, whether they serve us or hinder us. Negative behaviors, if repeated consistently, become entrenched, just as positive ones do. This highlights the responsibility inherent in repetition. Every repeated action carries consequences, not only in the moment, but cumulatively over time. Awareness of this principle allows individuals to intentionally choose what they repeat, harnessing the transformative power of repetition to build desirable behaviors and dismantle undesirable ones. Understanding the mechanisms of repetition provides powerful insight into personal development. It demonstrates that significant transformation rarely occurs in a single dramatic act. Rather, it is the accumulation of small, consistent actions over time that produces enduring change. Every step, every motion, every choice, repeated faithfully, contributes to the invisible architecture of habits, gradually shaping the mind, the body, and the life of the individual. The ordinary becomes extraordinary through repetition, and the mundane becomes instinctive through persistent effort. Ultimately, the story of habit formation is a story of repetition, patient, deliberate, often invisible, yet profoundly transformative. Repetition carves neural pathways, strengthens memory, regulates emotion, defines identity, and elevates behavior from conscious effort to instinctive action. It is the bridge between intention and automaticity, the mechanism through which ordinary choices become enduring patterns. By appreciating the power of repeated action, individuals gain the ability to shape their own lives intentionally, cultivating habits that align with their goals, values, and aspirations. Every repetition is a building block, every repeated action a step toward mastery, instinct, and the deliberate shaping of the self. In the final measure, repetition is not merely a tool, it is the essence of growth. It is the quiet, unheralded force that turns effort into skill, choice into habit, and habit into instinct. Across the arc of human life, from the first faltering steps to the most practiced actions of adulthood, it is repetition that molds potential into reality, creating the habits that define who we are, how we act, and how we navigate the world. Without repetition, no skill becomes skillful, no behavior becomes habitual, no life becomes intentional. With repetition, every small action contributes to the extraordinary architecture of human behavior, shaping the mind, the body, and ultimately, the very nature of our existence. From the earliest moments of human experience, the brain has been quietly, relentlessly adapting. Every sensation, every thought, every movement leaves an imprint, subtly reshaping the intricate network of neurons that defines our very being. This remarkable adaptability, known as neuroplasticity, is the cornerstone of how repeated actions eventually become automatic, freeing the conscious mind from the burden of constant decision-making. Imagine a sculptor working tirelessly on a block of marble. With each deliberate strike, the rough edges are refined, and over time, the form emerges naturally, as if it were always there. In the same way, the brain sculpts itself through repeated experiences, gradually rewiring to execute familiar behaviors with ease and efficiency. At the core of this process is the brain's unyielding desire for efficiency. Conscious thought, while powerful, is energetically expensive. Focusing intently on every small action, analyzing every decision, and evaluating every possible outcome consumes resources that the brain prefers to conserve. By creating automated pathways for repeated behaviors, the brain reduces this cognitive load, allowing attention and energy to be directed toward new challenges and novel stimuli. In essence, the brain rewards repetition with freedom, granting automaticity to behaviors that have proven reliable and beneficial. Consider, for example, the act of typing on a keyboard. For a beginner, typing requires careful attention. Eyes track each letter, fingers hesitate between keys, and mistakes are frequent. Yet over time, through countless repetitions, the brain rewires itself. Neural circuits strengthen, connections between sensory input and motor output become faster and more precise, and what once required conscious focus transforms into fluid, almost instinctive action. The fingers move as if guided by memory rather than deliberation. This process is not limited to typing. It applies to any behavior repeated frequently, from driving a car to playing a musical instrument to navigating familiar routes in a city. This transformation relies on a delicate interplay between neurons. When an action is repeated, the neurons responsible for that behavior fire together, sending chemical and electrical signals across synapses. With each repetition, these connections are reinforced, increasing the speed and efficiency of the pathway. Neuroscientists often describe this phenomenon with the phrase, "Neurons that fire together, wire together." Over time, the repeated firing creates a stable and reliable network capable of sustaining behavior with minimal conscious oversight. The brain essentially lays down a highway for the action, allowing traffic to flow smoothly without the need for constant guidance from the central executive system. As these neural pathways strengthen, the brain also adjusts the role of different regions. Initially, the prefrontal cortex, responsible for planning, decision making, and conscious control, is heavily engaged. Every action is deliberate and requires focused attention. However, as repetition continues, responsibility gradually shifts to the basal ganglia, a region deeply involved in habit formation and procedural memory. This shift signifies a crucial milestone. Behaviors once demanding conscious effort become largely automatic. The brain has optimized the process, reserving its most precious resources for novel challenges while routine behaviors unfold effortlessly. This rewiring is not instantaneous. It is a slow, cumulative process. Early attempts at a new skill or behavior are often awkward, filled with error, and mentally exhausting. The brain is still learning, still building the necessary connections to support automatic execution. Each repetition acts as a tiny reinforcement, strengthening the pathway and increasing reliability. Mistakes are informative, signaling where connections need to be refined or where additional practice is necessary. Gradually, through persistence and repetition, the pathway becomes more robust, allowing the action to be performed smoothly, consistently, and with minimal conscious oversight. Beyond physical skills, the brain's capacity to rewire itself applies to cognitive and emotional patterns as well. Repeated thought patterns, decision-making strategies, and emotional responses create their own neural pathways, which, over time, become automatic. A person who repeatedly practices mindfulness, for example, strengthens the neural circuits associated with attention, awareness, and emotional regulation. Similarly, someone who habitually engages in negative self-talk reinforces circuits that perpetuate stress, anxiety, or pessimism. Repetition, in this context, is a double-edged sword. It can produce either adaptive, beneficial behaviors or maladaptive, harmful ones. The brain does not distinguish between the two. It strengthens what is practiced most frequently. Reward and feedback are crucial components in this process. Each time a behavior is repeated and yields a positive outcome, the brain releases neurotransmitters such as dopamine, signaling satisfaction and reinforcing the neural pathway associated with action. This reward-driven reinforcement accelerates the rewiring process, making it more likely that the behavior will be repeated in the future. Even small, subtle rewards, such as the satisfaction of completing a task or the relief of avoiding a negative consequence, contribute to this reinforcement. Over time, the repeated behavior becomes deeply embedded, transitioning from conscious effort to automatic execution. Contextual cues further enhance the brain's ability to automate repeated behaviors. Time of day, environment, and associated stimuli act as triggers, signaling the brain to initiate the behavior without conscious deliberation. For instance, seeing a toothbrush on the bathroom sink, hearing an alarm in the morning, or arriving at a gym can automatically activate the neural circuits associated with brushing teeth, waking up, or exercising. These cues provide predictable conditions under which the brain can rely on established pathways, further reducing the need for conscious control. Repetition, combined with consistent context, accelerates the process of automation, ensuring that behaviors are executed efficiently and reliably. The transition from conscious effort to automaticity carries profound implications for learning and performance. Experts in any field rely heavily on this process. A concert pianist does not consciously deliberate over every note during a performance. A seasoned athlete does not calculate every movement mid-game. Years of repetition have rewired the brain, transferring control from conscious decision-making centers to neural circuits optimized for speed, precision, and efficiency. This automation is what allows for fluidity, creativity, and the ability to handle complex tasks under pressure. Repetition also interacts with emotional regulation, providing stability and predictability in daily life. Repeated behaviors, whether physical, cognitive, or emotional, create dependable routines that the brain can rely upon. Activities such as meditation, journaling, or habitual exercise become automated coping mechanisms, reducing stress and conserving cognitive energy. Over time, these repeated actions form patterns that influence emotional responses, reinforcing calm, resilience, and self-control. The brain's rewiring through repetition, therefore, is not merely a physical process. It is deeply intertwined with emotional well-being and psychological stability. Another critical aspect of this neural adaptation is the formation of identity. Behaviors repeated consistently are internalized as part of the self. The brain begins to associate repeated actions with personal identity, subtly shaping self-perception and influencing future choices. Someone who exercises daily or engages in regular creative work internalizes these behaviors as defining characteristics, reinforcing a cycle of repetition that becomes self-sustaining. In this way, the brain's ability to rewire itself in response to repeated behaviors contributes not only to automaticity, but also to the development of character and personal identity. The malleability of the brain extends to both positive and negative behaviors. Habits are not inherently beneficial. They are neutral processes shaped by repetition. Maladaptive behaviors, addictions, and harmful thought patterns can become entrenched through repeated practice, just as beneficial skills and positive habits can. Understanding the brain's ability to rewire itself emphasizes the responsibility inherent in repetition. Every repeated action leaves a lasting imprint. The choices we make, even in small daily behaviors, shape neural architecture, determining which pathways are strengthened and which fade into disuse. Finally, the cumulative effect of repeated behaviors illustrates the transformative power of consistency. Over time, the brain's rewiring enables actions to unfold with remarkable efficiency, minimizing conscious effort while maximizing reliability and precision. What begins as laborious and deliberate becomes seamless and automatic, illustrating the brain's extraordinary capacity for adaptation. Repetition, in this sense, is the engine that drives the transition from conscious effort to automatic behavior, demonstrating the profound interplay between experience, neural plasticity, and the formation of habits. As the brain continues to adapt to repeated behaviors, the patterns that emerge do more than streamline individual actions. They create a foundation for complex skills, advanced learning, and even creativity. The rewiring process enables sequences of behavior to occur almost without thought, freeing the conscious mind to focus on innovation, strategy, and problem solving. For example, A chess master does not deliberate over every pawn move. A seasoned chef does not measure every ingredient consciously. These individuals rely on neural circuits refined through repetition, allowing mastery and intuition to emerge. The brain's ability to rewire itself ensures that repeated practice transforms not only the mechanics of behavior, but the very capacity to perform at higher levels. Neuroscience has shown that the basal ganglia, a region deep within the brain, plays a pivotal role in this transformation. Initially, new behaviors engage the prefrontal cortex, demanding conscious attention and decision-making. With repetition, the basal ganglia gradually assumes control, automating the behavior and reducing cognitive effort. This transfer allows the conscious mind to focus on novel challenges, while routine behaviors proceed without interruption. Over time, the brain becomes a finely tuned system, balancing automated habits with adaptive conscious thought, illustrating how repeated behaviors shape not only action but cognitive architecture. Memory plays a crucial role in this process. Procedural memory, which governs skills and routines, is strengthened with every repetition. Unlike declarative memory, which requires conscious recall, procedural memory allows complex sequences to unfold automatically. Typing a sentence, driving a familiar route, or performing a musical piece relies on this system. Each repetition reinforces the memory trace, creating reliable and rapid responses. Over time, the brain no longer needs to deliberate over every step. The behavior becomes encoded in the neural circuitry, executed smoothly and instinctively. Reward mechanisms further accelerate the brain's rewiring. Every successful repetition releases neurotransmitters such as dopamine, signaling satisfaction and reinforcing the pathway associated with the behavior. This chemical reinforcement ensures that the behavior is repeated, further strengthening the neural connections. The process is self-reinforcing. Repeated action strengthens pathways, reward reinforces repetition, and repetition deepens automation. Even minor, consistent rewards like the feeling of completing a task or the satisfaction of a correct response contribute to this feedback loop, gradually embedding behaviors into automatic execution. Environmental cues amplify the process. Habits and behaviors often become associated with specific contexts, times, or stimuli. A person who always exercises in the morning or reviews notes at a particular desk uses environmental triggers to activate established neural circuits. These cues reduce the need for conscious decision-making, prompting automatic behaviors in predictable contexts. Repetition, in conjunction with contextual consistency, ensures that the brain can rely on established pathways, making behaviors efficient, reliable, and largely unconscious. The rewiring process also influences emotional patterns. Repeated behaviors, especially those associated with coping, reflection, or mindfulness, create neural circuits that regulate emotional responses. Meditation, journaling, or consistent physical activity, when repeated, teach the brain to respond to stressors with calm and resilience. Over time, these behaviors become automatic responses, allowing the individual to manage emotional challenges without significant cognitive effort. The brain's capacity to rewire itself extends beyond action. It shapes emotional regulation, resilience, and psychological stability. Repetition also affects identity formation. The behaviors we perform consistently become ingrained in our sense of self. Someone who writes daily, practices gratitude, or engages in regular physical training internalizes these repeated actions as defining aspects of who they are. The brain begins to associate repeated actions with personal identity, creating a feedback loop. Repeated behavior shapes self-perception, and self-perception reinforces repetition. This interplay between action and identity highlights the profound influence of neural rewiring on both habit and character development. Negative behaviors are equally susceptible to this process. Just as repeated practice can strengthen beneficial actions, maladaptive behaviors, addictive patterns, and harmful thought processes become deeply embedded through repetition. Smoking, excessive screen use, negative self-talk, or impulsive reactions to stress can all become automated through repeated engagement. The brain does not discriminate between positive and negative behaviors. Repetition is the universal driver of automaticity. Recognizing this empowers individuals to intentionally cultivate beneficial habits while dismantling harmful ones, harnessing the brain's rewiring capacity to shape life constructively. Learning, skill acquisition, and performance all rely on repeated behaviors to rewire the brain. Musicians spend hours practicing scales. Athletes repeat drills countless times, and writers revise and rewrite passages until expression flows effortlessly. Each repetition strengthens pathways, automates sequences, and builds precision. The result is not merely competence, it is mastery, the ability to perform complex actions with fluidity and minimal conscious effort. Neural rewiring transforms deliberate practice into instinctive performance, demonstrating the extraordinary adaptability of the brain in response to repetition. The cumulative effects of repeated behavior extend to societal and cultural patterns. Repetition underpins traditions, rituals, and social norms. Daily greetings, ceremonial practices, or professional routines persist because repeated engagement rewires collective behavior into automatic cultural patterns. At the individual level, repeated actions reinforce identity and efficiency. At the collective level, repetition shapes communities, cultures, and social systems. The brain's capacity for rewiring ensures that both personal and societal habits emerge from consistent engagement over time. Neuroplasticity, the brain's capacity to reorganize itself, illustrates that repeated behaviors are never static. Even well-established habits can be reshaped, replaced, or refined through deliberate repetition. This adaptability highlights the potential for growth and transformation at any stage of life. By engaging in repeated practice, individuals can create new neural pathways, strengthen desirable behaviors, and diminish maladaptive ones. The brain's rewiring is ongoing, a dynamic interplay of repetition, reinforcement, and adaptation that continues across the lifespan. In addition, repeated behaviors create efficiency by reducing cognitive load. When actions are automated, the brain conserves energy, allowing conscious thought to focus on novel or complex tasks. Habits formed through repetition become reliable tools, executed without effort, while the mind is freed to innovate, problem, solve, and adapt to changing circumstances. This efficiency is a testament to the brain's ingenuity. It optimizes behavior, rewards reliability, and constantly seeks to minimize effort while maximizing effectiveness. Finally, the profound significance of repeated behavior lies in its cumulative, transformative power. Every small action, performed consistently, leaves a lasting neural imprint. Over time, these imprints accumulate, resulting in automatic behaviors, refined skills, emotional regulation, and even the shaping of identity. The brain's capacity to rewire itself in response to repetition ensures that effort, patience, and persistence translate into lasting change. Repetition is not merely a mechanism for learning. It is the foundation for transformation, the invisible force that converts conscious effort into instinctive, effortless action. In the grand narrative of human life, the brain's rewiring demonstrates the extraordinary potential embedded in repeated behavior. Through repetition, behaviors once demanding conscious thought evolve into automatic patterns. Neural pathways strengthen, emotional regulation improves, and identity becomes aligned with repeated actions. This process is not limited to extraordinary feats. It governs daily routines, personal growth, skill acquisition, and social interactions. The brain's ability to rewire itself is both a testament to human adaptability and a blueprint for intentional living. Ultimately, the story of repetition and neural rewiring is a story of empowerment. By understanding that repeated behaviors reshape the brain, individuals gain the capacity to intentionally craft habits, refine skills, and influence personal and emotional development. Every repetition is a step toward automaticity, every practiced behavior a building block of identity, and every consistent action a contribution to the invisible architecture of the mind. The brain rewires itself not passively, but actively in response to repeated engagement, illustrating that mastery, resilience, and instinct are built not overnight, but through persistent, deliberate, and continuous action. Human behavior has always been guided, in part, by the forces of reward and consequence. From the earliest days of survival, the outcomes of actions shaped choices, directed attention, and reinforced behaviors that increased the likelihood of continued life. A child learning to avoid a hot stove, an early hunter discovering which strategies yield food, or a social group recognizing actions that maintain cohesion, all illustrate the ancient, underlying principle: behavior is shaped by its outcomes. This principle, deeply ingrained in both our biology and psychology, underpins the process of habit formation. Repeated actions are rarely automatic from the outset. They are learned, practiced, and reinforced through the interplay of positive and negative consequences. Without such reinforcement, behaviors remain tentative, fleeting, or inconsistent. From the moment a behavior is performed, the brain evaluates its results. A pleasurable outcome, however small, signals that the action is worthwhile and worthy of repetition. The release of neurotransmitters such as dopamine creates a sensation of satisfaction, encouraging the individual to engage in the behavior again. Even subtle rewards, a nod of approval, a sense of accomplishment, the relief of completing a task, carry the power to reinforce action. The brain associates the behavior with positive outcomes, forming a neural memory of reward. Repetition of the action strengthens this connection, gradually embedding the behavior into daily life. In this way, rewards act as both motivation and reinforcement, silently sculpting patterns that can endure for years or even a lifetime. Consequences operate in a complementary fashion. While rewards encourage repetition, negative outcomes deter behaviors that are harmful, inefficient, or undesirable. Pain, discomfort, social disapproval, or failure all serve as signals to the brain that a particular action carries risk or is counterproductive. The interplay of reward and consequence creates a dynamic feedback loop. Actions that produce positive outcomes are reinforced, while actions that produce negative outcomes are suppressed or avoided. Through countless iterations, the brain begins to identify reliable patterns, forming habits that maximize benefit and minimize harm. This process is fundamental to human learning, enabling behaviors to become consistent, efficient, and adaptive. Consider, for example, the act of learning a new skill, such as playing a musical instrument. Early attempts are often frustrating, filled with mistakes, missed notes, and awkward transitions. Yet, each successful chord, each correctly played sequence, provides a small but meaningful reward. The brain registers the success, releasing chemicals that create pleasure and reinforce the pathway associated with the action. Simultaneously, errors act as negative feedback, guiding the learner to adjust, refine technique, and improve performance. Over time, the interplay of reward and consequence transforms trial and error into proficiency. What once required conscious focus evolves into fluidity and eventually into automatic execution. The behavior becomes habitual, not through mere repetition alone, but through reinforcement shaped by outcomes. This principle applies not only to skill acquisition, but to every aspect of human behavior. Daily routines, decision-making processes, and social interactions are all influenced by the mechanisms of reward and consequence. Brushing teeth, exercising, completing work tasks, or engaging in meaningful conversation. All are behaviors shaped by feedback. Positive reinforcement encourages consistency, while negative consequences prevent deviation. Over time, the cumulative effect of these forces establishes patterns that guide behavior with remarkable efficiency. The brain learns to anticipate outcomes, and actions that consistently produce favorable results become ingrained, forming the backbone of habitual conduct. Rewards are not always tangible. They can be subtle, internal, or psychological. A sense of pride, the pleasure of solving a problem, or the relief of avoiding conflict all function as reinforcement. The brain is highly attuned to these internal signals, integrating them with external outcomes to guide behavior. Even small, repeated psychological rewards can significantly strengthen a habit. The pleasure derived from completing a morning routine, practicing a skill, or finishing a creative task can be enough to encourage repetition, particularly when combined with consistency and conscious intent. In this way, internal rewards often operate alongside external incentives, creating a layered reinforcement system that accelerates habit formation. Consequences similarly extend beyond the physical or immediate. Social and emotional feedback often influences behavior more strongly than material outcomes. Disapproval, criticism, embarrassment, or rejection signals to the brain that an action carries social cost, prompting adjustment or avoidance. Conversely, recognition, praise, or acceptance reinforces behaviors that align with social norms and personal values. Human beings are inherently social creatures, and the brain has evolved to monitor outcomes not only in the physical domain, but in the social and emotional realms as well. Habits are therefore shaped as much by social and emotional consequences as by tangible rewards, highlighting the multidimensional nature of reinforcement. The role of feedback in habit formation demonstrates that repetition alone is rarely sufficient to create enduring behaviors. While repeated action strengthens neural pathways, the brain relies on reinforcement to determine which pathways are valuable and worth sustaining. Without feedback, repetition risks becoming mechanical or meaningless. Rewards and consequences act as navigational signals, guiding behavior toward reliability, efficiency, and adaptiveness. Over time, the repeated association of behavior with outcomes embeds actions into patterns that can operate with minimal conscious oversight. Habits, then, are not merely the product of repetition. They are the product of informed repetition, shaped by the consequences of action. This process also illuminates why habit change can be challenging. Existing habits are reinforced by a lifetime of accumulated reward and consequence, creating robust neural pathways that resist disruption. Attempts to alter behavior must contend with these established patterns. To replace a habit, the brain must experience new rewards associated with alternative behaviors, while simultaneously diminishing the reinforcement of the existing habit. Change is therefore not simply a matter of willpower. It is a matter of restructuring the relationship between action and outcome, gradually rewiring the brain to prioritize new patterns of behavior. The process is deliberate, incremental, and often requires sustained attention, but it is achievable precisely because the brain is designed to respond to reinforcement. Reward and consequence also influence motivation, a critical factor in the initial adoption of behaviors. The anticipation of positive outcomes drives effort and persistence, while the awareness of negative outcomes shapes caution and self-regulation. Motivation interacts with repetition to accelerate the formation of habits. Repeated behaviors that consistently produce reward become more appealing, more automatic, and more likely to recur. Conversely, behaviors that repeatedly produce undesirable consequences are avoided, leading to extinction of the habit. This dynamic underscores the intertwined nature of action, outcome, and repetition in the architecture of human behavior. Over longer periods, the accumulation of reinforced behaviors creates complex patterns that govern daily life. Morning routines, work habits, exercise schedules, study patterns, and social rituals all emerge from repeated behaviors shaped by reward and consequence. These behaviors become automatic, freeing the conscious mind to focus on creativity, planning, and problem solving. Without the guiding influence of reinforcement, repeated actions may lack direction or fail to persist. Reward and consequence provide the structure that allows repetition to translate into habit, habit into routine, and routine into instinctive behavior. The brain's responsiveness to reward and consequence is not uniform across individuals. Genetics, personal experiences, and cultural context all influence sensitivity to reinforcement. Some individuals respond more strongly to external reward, while others rely heavily on internal motivation. Some are more deterred by negative consequences, while others exhibit resilience in the face of feedback. Despite these differences, the fundamental principle remains. Behavior is guided, reinforced, and embedded through the interaction of outcomes with repeated action. Understanding this interplay provides insight into why habits form, persist, and sometimes resist change. Scientific research into habit formation underscores the centrality of reward and consequence. Studies of learning in animals and humans reveal that behaviors followed by rewarding outcomes are more likely to be repeated, while behaviors followed by aversive outcomes are suppressed. Neuroimaging studies show that the brain's reward centers, including the striatum and prefrontal cortex, are actively involved in habit learning, processing the outcomes of action and reinforcing neural circuits associated with repeated behaviors. These findings demonstrate that habit formation is not random. It is a highly structured, biologically driven process shaped by the consequences of action. Even small, consistent rewards can have a disproportionate effect over time. The brain is sensitive to patterns of reinforcement, and repeated positive outcomes, however modest, accumulate to create powerful neural and behavioral changes. Similarly, consistent negative feedback, when properly calibrated, guides the brain toward adaptive behavior. This dual system of reward and consequence forms the foundation for not only skill development, but also moral, social, and emotional learning. Habits are therefore both biological and psychological constructs, arising from the brain's intrinsic capacity to link action with outcome. In the context of personal growth, the principle of reward and consequence provides practical guidance. To cultivate new habits, one must design behaviors that provide consistent positive feedback or meaningful reward. Likewise, reducing or modifying negative outcomes associated with undesired behaviors can weaken reinforcement and support habit change. The deliberate alignment of action with outcome through tangible rewards, social support, or emotional satisfaction is central to transforming repetition into enduring habit. The narrative of habit formation is, ultimately, the narrative of consequence and reward. Every repeated behavior interacts with the brain's evaluation of outcome, gradually shaping patterns that guide action with precision and efficiency. Over time, this process transforms conscious effort into automatic behavior, integrating physical, cognitive, and emotional responses. Habits are not simply repeated actions. They are behaviors forged in the crucible of feedback, refined by consequence, and stabilized by reward. They represent the brain's capacity to learn, adapt, and optimize in response to the environment, ensuring that actions which produce beneficial outcomes endure, while those that do not fade into disuse. In sum, the shaping of behavior through reward and consequence illustrates the profound intelligence of the human brain. Repeated behaviors, when consistently reinforced by positive outcomes or tempered by negative ones, become durable, automatic, and instinctive. This principle applies across the spectrum of human life, from the acquisition of skills to the maintenance of routines, from emotional regulation to social conduct. Understanding this mechanism reveals not only how habits are formed, but also how they can be intentionally cultivated, modified, and optimized. Reward and consequence are the silent architects of behavior, quietly guiding the mind and body toward patterns that endure, ultimately shaping the course of a life built on repeated, reinforced action. Human behavior has always been guided, in part, by the forces of reward and consequence. From the earliest days of survival, the outcomes of actions shaped choices, directed attention, and reinforced behaviors that increased the likelihood of continued life. A child learning to avoid a hot stove, an early hunter discovering which strategies yield food, or a social group recognizing actions that maintain cohesion, all illustrate the ancient, underlying principle: behavior is shaped by its outcomes. This principle, deeply ingrained in both our biology and psychology, underpins the process of habit formation. Repeated actions are rarely automatic from the outset. They are learned, practiced, and reinforced through the interplay of positive and negative consequences. Without such reinforcement, behaviors remain tentative, fleeting, or inconsistent. From the moment a behavior is performed, the brain evaluates its results. A pleasurable outcome, however small, signals that the action is worthwhile and worthy of repetition. The release of neurotransmitters such as dopamine creates a sensation of satisfaction, encouraging the individual to engage in the behavior again. Even subtle rewards, a nod of approval, a sense of accomplishment, the relief of completing a task, carry the power to reinforce action. The brain associates the behavior with positive outcomes, forming a neural memory of reward. Repetition of the action strengthens this connection, gradually embedding the behavior into daily life. In this way, rewards act as both motivation and reinforcement, silently sculpting patterns that can endure for years or even a lifetime. Consequences operate in a complementary fashion. While rewards encourage repetition, negative outcomes deter behaviors that are harmful, inefficient, or undesirable. Pain, discomfort, social disapproval, or failure all serve as signals to the brain that a particular action carries risk or is counterproductive. The interplay of reward and consequence creates a dynamic feedback loop. Actions that produce positive outcomes are reinforced, while actions that produce negative outcomes are suppressed or avoided. Through countless iterations, the brain begins to identify reliable patterns, forming habits that maximize benefit and minimize harm. This process is fundamental to human learning, enabling behaviors to become consistent, efficient, and adaptive. Consider, for example, the act of learning a new skill, such as playing a musical instrument. Early attempts are often frustrating, filled with mistakes, missed notes, and awkward transitions. Yet, each successful chord, each correctly played sequence, provides a small but meaningful reward. The brain registers the success, releasing chemicals that create pleasure and reinforce the pathway associated with the action. Simultaneously, errors act as negative feedback, guiding the learner to adjust, refine technique, and improve performance. Over time, the interplay of reward and consequence transforms trial and error into proficiency. What once required conscious focus evolves into fluidity and eventually into automatic execution. The behavior becomes habitual, not through mere repetition alone, but through reinforcement shaped by outcomes. This principle applies not only to skill acquisition, but to every aspect of human behavior. Daily routines, decision-making processes, and social interactions are all influenced by the mechanisms of reward and consequence. Brushing teeth, exercising, completing work tasks, or engaging in meaningful conversation. All are behaviors shaped by feedback. Positive reinforcement encourages consistency, while negative consequences prevent deviation. Over time, the cumulative effect of these forces establishes patterns that guide behavior with remarkable efficiency. The brain learns to anticipate outcomes, and actions that consistently produce favorable results become ingrained, forming the backbone of habitual conduct. Rewards are not always tangible. They can be subtle, internal, or psychological. A sense of pride, the pleasure of solving a problem, or the relief of avoiding conflict all function as reinforcement. The brain is highly attuned to these internal signals, integrating them with external outcomes to guide behavior. Even small, repeated psychological rewards can significantly strengthen a habit. The pleasure derived from completing a morning routine, practicing a skill, or finishing a creative task can be enough to encourage repetition, particularly when combined with consistency and conscious intent. In this way, internal rewards often operate alongside external incentives, creating a layered reinforcement system that accelerates habit formation. Consequences similarly extend beyond the physical or immediate. Social and emotional feedback often influences behavior more strongly than material outcomes. Disapproval, criticism, embarrassment, or rejection signals to the brain that an action carries social cost, prompting adjustment or avoidance. Conversely, recognition, praise, or acceptance reinforces behaviors that align with social norms and personal values. Human beings are inherently social creatures, and the brain has evolved to monitor outcomes not only in the physical domain, but in the social and emotional realms as well. Habits are therefore shaped as much by social and emotional consequences as by tangible rewards, highlighting the multidimensional nature of reinforcement. The role of feedback in habit formation demonstrates that repetition alone is rarely sufficient to create enduring behaviors. While repeated action strengthens neural pathways, the brain relies on reinforcement to determine which pathways are valuable and worth sustaining. Without feedback, repetition risks becoming mechanical or meaningless. Rewards and consequences act as navigational signals, guiding behavior toward reliability, efficiency, and adaptiveness. Over time, the repeated association of behavior with outcomes embeds actions into patterns that can operate with minimal conscious oversight. Habits, then, are not merely the product of repetition. They are the product of informed repetition, shaped by the consequences of action. This process also illuminates why habit change can be challenging. Existing habits are reinforced by a lifetime of accumulated reward and consequence, creating robust neural pathways that resist disruption. Attempts to alter behavior must contend with these established patterns. To replace a habit, the brain must experience new rewards associated with alternative behaviors, while simultaneously diminishing the reinforcement of the existing habit. Change is therefore not simply a matter of willpower. It is a matter of restructuring the relationship between action and outcome, gradually rewiring the brain to prioritize new patterns of behavior. The process is deliberate, incremental, and often requires sustained attention, but it is achievable precisely because the brain is designed to respond to reinforcement. Reward and consequence also influence motivation, a critical factor in the initial adoption of behaviors. The anticipation of positive outcomes drives effort and persistence, while the awareness of negative outcomes shapes caution and self-regulation. Motivation interacts with repetition to accelerate the formation of habits. Repeated behaviors that consistently produce reward become more appealing, more automatic, and more likely to recur. Conversely, behaviors that repeatedly produce undesirable consequences are avoided, leading to extinction of the habit. This dynamic underscores the intertwined nature of action, outcome, and repetition in the architecture of human behavior. Over longer periods, the accumulation of reinforced behaviors creates complex patterns that govern daily life. Morning routines, work habits, exercise schedules, study patterns, and social rituals all emerge from repeated behaviors shaped by reward and consequence. These behaviors become automatic, freeing the conscious mind to focus on creativity, planning, and problem solving. Without the guiding influence of reinforcement, repeated actions may lack direction or fail to persist. Reward and consequence provide the structure that allows repetition to translate into habit, habit into routine, and routine into instinctive behavior. The brain's responsiveness to reward and consequence is not uniform across individuals. Genetics, personal experiences, and cultural context all influence sensitivity to reinforcement. Some individuals respond more strongly to external reward, while others rely heavily on internal motivation. Some are more deterred by negative consequences, while others exhibit resilience in the face of feedback. Despite these differences, the fundamental principle remains. Behavior is guided, reinforced, and embedded through the interaction of outcomes with repeated action. Understanding this interplay provides insight into why habits form, persist, and sometimes resist change. Scientific research into habit formation underscores the centrality of reward and consequence. Studies of learning in animals and humans reveal that behaviors followed by rewarding outcomes are more likely to be repeated, while behaviors followed by aversive outcomes are suppressed. Neuroimaging studies show that the brain's reward centers, including the striatum and prefrontal cortex, are actively involved in habit learning, processing the outcomes of action and reinforcing neural circuits associated with repeated behaviors. These findings demonstrate that habit formation is not random. It is a highly structured, biologically driven process shaped by the consequences of action. Even small, consistent rewards can have a disproportionate effect over time. The brain is sensitive to patterns of reinforcement, and repeated positive outcomes, however modest, accumulate to create powerful neural and behavioral changes. Similarly, consistent negative feedback, when properly calibrated, guides the brain toward adaptive behavior. This dual system of reward and consequence forms the foundation for not only skill development, but also moral, social, and emotional learning. Habits are therefore both biological and psychological constructs, arising from the brain's intrinsic capacity to link action with outcome. In the context of personal growth, the principle of reward and consequence provides practical guidance. To cultivate new habits, one must design behaviors that provide consistent positive feedback or meaningful reward. Likewise, reducing or modifying negative outcomes associated with undesired behaviors can weaken reinforcement and support habit change. The deliberate alignment of action with outcome through tangible rewards, social support, or emotional satisfaction is central to transforming repetition into enduring habit. The narrative of habit formation is, ultimately, the narrative of consequence and reward. Every repeated behavior interacts with the brain's evaluation of outcome, gradually shaping patterns that guide action with precision and efficiency. Over time, this process transforms conscious effort into automatic behavior, integrating physical, cognitive, and emotional responses. Habits are not simply repeated actions. They are behaviors forged in the crucible of feedback, refined by consequence, and stabilized by reward. They represent the brain's capacity to learn, adapt, and optimize in response to the environment, ensuring that actions which produce beneficial outcomes endure, while those that do not fade into disuse. In sum, the shaping of behavior through reward and consequence illustrates the profound intelligence of the human brain. Repeated behaviors, when consistently reinforced by positive outcomes or tempered by negative ones, become durable, automatic, and instinctive. This principle applies across the spectrum of human life, from the acquisition of skills to the maintenance of routines, from emotional regulation to social conduct. Understanding this mechanism reveals not only how habits are formed, but also how they can be intentionally cultivated, modified, and optimized. Reward and consequence are the silent architects of behavior, quietly guiding the mind and body toward patterns that endure, ultimately shaping the course of a life built on repeated, reinforced action. Every action humans perform is influenced, often subtly, by the environment in which it occurs. The brain, constantly scanning for signals, is attuned to cues that predict outcomes and guide behavior. Over time, these environmental signals, sounds, sights, smells, or even times of day become associated with repeated actions, prompting behaviors almost automatically. The smell of fresh coffee can trigger the desire to brew a cup. The sound of a phone notification can prompt checking a message, and arriving at a gym can cue the start of a familiar workout routine. These cues act as silent orchestrators, shaping daily life by signaling when a behavior is appropriate or necessary, and they play a central role in transforming deliberate actions into habits. The process begins with repeated pairing. When a specific cue consistently precedes an action, the brain forms a link between the two. A child who hears a bedtime song before brushing teeth learns to associate the music with the act of preparation for sleep. Over time, the mere sound of the song triggers the behavior, even without conscious thought. This associative learning extends to countless behaviors, from the most routine to the most complex. The brain, ever efficient, recognizes patterns in the environment and uses them to predict what action is expected, minimizing the need for conscious deliberation. Cues operate at multiple levels. Physical objects, such as a toothbrush on the counter or running shoes by the door, provide visual triggers. Temporal cues, such as a specific hour of the day, prompt routine activities like waking, eating, or exercise. Social cues, including the presence of others or culturally defined rituals, can trigger behaviors that align with norms and expectations. Even internal cues, such as hunger, fatigue, or emotional states, serve as signals for action. The brain integrates these diverse cues, forming a sophisticated system for initiating habitual behavior, often before conscious awareness can intervene. The impact of environmental triggers on habits is amplified by repetition. Each time a cue reliably leads to a specific behavior, the neural pathways connecting perception to action are strengthened. The basal ganglia, the brain region associated with habit formation, becomes more active, allowing the behavior to occur automatically. This means that over time, encountering the cue produces near-instantaneous behavioral responses without the need for conscious planning. This automaticity is why certain routines feel effortless. The brain has learned to act efficiently in response to familiar signals. Cues can also explain why habits persist even in new contexts. When an environment contains multiple familiar triggers, behaviors that were once intentional can re-emerge with surprising consistency. A person returning to an old neighborhood may find themselves visiting a favorite coffee shop without conscious planning, prompted by visual and spatial cues embedded in the surroundings. Similarly, a particular scent, song, or sound can evoke habits long dormant, demonstrating the brain's capacity to link environmental stimuli with learned behaviors over extended periods. Understanding the role of cues also provides insight into behavior modification. To create new habits, one can intentionally design environmental triggers to prompt desired actions. Placing a water bottle on the desk encourages regular hydration, keeping a journal by the bed cues nightly reflection. Conversely, reducing or removing cues associated with unwanted behaviors can weaken habits, making them easier to break. By manipulating cues and triggers, individuals can harness the brain's natural responsiveness to environmental signals, guiding behavior toward intentional, constructive patterns. The subtle power of cues extends into emotional and cognitive realms. Certain locations, objects, or even colors can trigger moods, thought patterns, or levels of alertness, indirectly influencing behavior. A cluttered workspace may cue distraction, while an organized environment promotes focus. Over time, the brain learns to associate these environmental patterns with predictable mental and behavioral outcomes, shaping not only what is done, but how it is experienced. Ultimately, cues and triggers demonstrate that habits are rarely formed in isolation. They are embedded in a network of environmental signals that guide action, streamline decision making, and reduce cognitive effort. By recognizing and manipulating these cues, humans can better understand the mechanics of habit formation, gaining control over behaviors that might otherwise unfold unconsciously. Environmental triggers, silent and pervasive, are among the most powerful architects of routine, quietly directing human behavior and reinforcing the patterns that define daily life. Habits do not emerge overnight. They are the product of repeated, consistent actions performed over time. The brain, remarkable in its ability to adapt, relies on persistent repetition to reinforce neural pathways, ensuring that behaviors become reliable, efficient, and eventually automatic. Inconsistent or irregular actions rarely create the deep structural changes necessary for habit formation. Just as a path through a forest becomes well-trodden only when travelers walk it repeatedly, so too does behavior become habitual only when consistently practiced. Without persistence, the mind treats actions as isolated events rather than patterns worth reinforcing, and the cycle of automaticity cannot take hold. Consistency provides the brain with clear signals, establishing predictability and stability. Every repeated action strengthens the synaptic connections between neurons involved in that behavior, gradually increasing efficiency and reducing the cognitive effort required to execute it. When practice is erratic, these connections remain weak, preventing the behavior from moving from conscious intention to automatic execution. The prefrontal cortex must remain heavily involved to guide action, making the behavior effortful and unreliable. With consistent repetition, control gradually shifts to the basal ganglia, allowing the habit to unfold with minimal conscious attention. This transfer is critical for behaviors to become ingrained and sustainable over time. The psychological aspect of consistency is equally powerful. Humans are highly sensitive to patterns, and the brain naturally anticipates what is likely to occur based on past experience. When behaviors are repeated reliably, the brain expects the outcome and prepares the body and mind accordingly. A morning routine repeated each day triggers anticipatory signals. Muscles move automatically, thoughts align with the action, and attention is focused on predictable steps. Inconsistent routines fail to elicit these anticipatory responses, making behaviors feel foreign, effortful, or easily forgotten. Habit formation is therefore not only a matter of repetition, but of creating a reliable temporal and contextual framework for action. Even minor inconsistencies can delay habit formation. Skipping days, performing actions sporadically, or varying the sequence of behavior interrupts the reinforcement of neural pathways. Each interruption introduces variability that requires the brain to relearn or adjust, slowing progress toward automaticity. In contrast, maintaining a steady, disciplined approach ensures that neural circuits are strengthened systematically, producing habits that are resilient and reliable. Consistency transforms effort into ease, allowing behaviors to become integrated into the fabric of daily life without requiring constant conscious monitoring. Consistency also amplifies the power of reward and consequence. When actions are performed regularly, positive outcomes are experienced more frequently, reinforcing the behavior and embedding it in the brain's circuitry. Negative consequences, when associated with irregular behaviors, serve as corrective signals but are less effective if the action lacks repetition. The brain relies on repeated feedback to determine which behaviors are valuable, meaningful, or adaptive. By maintaining a consistent pattern of behavior, individuals maximize the reinforcement effect, accelerating the transition from deliberate action to automatic habit. Beyond neural reinforcement, consistent practice strengthens psychological commitment. The act of performing a behavior reliably reinforces identity and self-perception. A person who writes daily internalizes the identity of a writer. Someone who exercises each morning comes to see themselves as active and disciplined. Consistency signals to the mind that the behavior is important, aligned with goals, and worthy of attention. Over time, this alignment between action and identity further stabilizes the habit, making it resistant to disruption or neglect. Contextual consistency is also critical. Performing actions at the same time or in the same environment strengthens associations between cues and behavior, further reinforcing automaticity. A person who meditates in the same room each morning or studies at a particular desk creates a predictable framework that cues the brain to act without conscious thought. Irregular timing or shifting contexts weakens these associations, making the habit harder to maintain. The interplay between repetition, timing, and context highlights why consistency is not merely desirable but essential for deep habit formation. Finally, consistency provides momentum. Early stages of habit formation often feel effortful, and motivation can fluctuate. Reliable repetition bridges this gap, gradually transforming effort into ease and intention into automaticity. Each day of consistent action builds on the previous one, producing a cumulative effect that strengthens both neural pathways and psychological resolve. Over weeks and months, the behavior becomes self-sustaining, unfolding naturally in response to cues, reinforced by reward, and embedded in identity. In sum, consistency is the invisible engine that drives habit formation. It ensures that repetition produces structural changes in the brain, reinforces reward pathways, aligns behavior with identity, and integrates action into daily life. Without consistency, even well-intentioned efforts may falter, but with disciplined, regular practice, behaviors evolve from conscious effort to automatic routine. Habits, in their most enduring form, are the product of repeated, reliable action, patiently and persistently practiced until they become second nature. Habits, powerful though they may be, are not impervious to the influence of stress and fatigue. The brain, remarkable in its ability to automate behavior, relies on a delicate balance of energy, focus, and neural resources to maintain these automatic patterns. When stress levels rise or fatigue sets in, this balance is disrupted. Neural circuits that normally guide habitual behavior may falter. Attention becomes scattered, and decision-making processes are compromised. Actions that once occurred effortlessly can suddenly feel difficult or require conscious effort. The interplay between stress, fatigue, and habit reveals the fragile yet adaptive nature of human behavior. Stress triggers a cascade of physiological and chemical responses in the brain. The release of cortisol and other stress hormones alters activity in the prefrontal cortex, the area responsible for planning, reasoning, and self-control. While habits are largely governed by the basal ganglia, which operates independently of conscious oversight, stress can interfere with this system. When the brain is overwhelmed by perceived threats or high pressure, it may prioritize immediate survival strategies over routine behaviors. This can result in skipped habits, impulsive actions, or even complete behavioral lapses. The very mechanisms that allow habits to operate automatically become vulnerable when the body and mind are under strain. Fatigue compounds these effects by reducing cognitive and physical resources available for behavior. Neural circuits that coordinate habitual actions require energy to function effectively, and when energy reserves are low, these circuits may operate less efficiently. A tired person may struggle to maintain focus, skip established routines, or make errors in behaviors that are normally automatic. Even deeply ingrained habits, such as exercising, completing work tasks, or maintaining a diet, can be disrupted by prolonged mental or physical exhaustion. Fatigue, therefore, acts as a subtle yet potent force, undermining the reliability of habits and challenging the brain's capacity for automaticity. The effects of stress and fatigue are particularly evident in decision making. Habits serve to conserve mental energy by reducing the need for conscious deliberation, but under strain, the brain may default to either impulsive choices or complete inaction. For example, a person following a healthy eating routine may find themselves reaching for convenience food when stressed or tired, even if the behavior contradicts their long-term goals. Similarly, someone with a regular exercise habit may skip workouts after a long, exhausting day. The disruption occurs not because the habit has disappeared, but because the neural and emotional resources required to maintain it have been compromised. Stress and fatigue also interact with motivation and reward systems. When the brain is under duress, the perceived effort required to maintain a habit increases, while the sense of reward may diminish. The pleasure associated with completing a habitual action may feel muted, and the cost of exerting effort may feel disproportionately high. This can break the reinforcement cycle that strengthens habits, slowing or even reversing the process of habit consolidation. Over time, repeated exposure to stress and fatigue can weaken previously stable behaviors, illustrating the importance of mental and physical well-being in supporting habit formation. Interestingly, stress does not always undermine habits. It can sometimes enhance them. In familiar environments, under moderate stress, the brain may rely even more heavily on well-established routines to conserve energy and maintain performance. For example, experienced professionals under time pressure may default to practiced procedures, allowing habits to guide action efficiently. However, when stress is intense or prolonged, the protective effect diminishes, and habitual behavior may be overridden by reactive or impulsive responses. This demonstrates that the influence of stress is not uniform, but depends on intensity, duration, and the stability of the habit itself. Strategies to protect habits under stress and fatigue involve both environmental and internal interventions. Planning routines in predictable contexts, establishing external reminders, and creating structured cues can help preserve behavior when internal resources are low. Adequate rest, stress management techniques, and mindful attention to energy levels also support the maintenance of habits. By understanding the ways in which stress and fatigue affect the brain's capacity for automaticity, individuals can design strategies to reinforce habits even under challenging conditions. Ultimately, the interaction between stress, fatigue, and habit formation highlights the vulnerability and resilience of human behavior. Habits are powerful because they reduce cognitive effort and streamline action, but they are not immune to disruption. Environmental pressures, emotional strain, and physical exhaustion all influence the brain's ability to execute behaviors automatically. Recognizing this dynamic allows for a more nuanced understanding of habit maintenance. It is not simply repetition or consistency that matters, but the broader context of mental and physical health in which these habits exist. In conclusion, stress and fatigue serve as both obstacles and informants in the process of habit formation. They reveal the conditions under which habitual behavior thrives and falters, demonstrating that even well-established routines depend on adequate cognitive, emotional, and physiological resources. By accounting for these factors, individuals can better preserve, adapt, and strengthen their habits, ensuring that the routines designed to support goals and well-being endure even in the face of Life's inevitable challenges. The brain's capacity for automatic behavior is remarkable, but it is continually influenced by the body and environment, reminding us that habits are living processes, sensitive to the ebbs and flows of human experience. Habits are not merely repeated actions. They are the building blocks of identity. Over time, the behaviors we perform consistently begin to define who we are, influencing not only daily routines, but also our sense of self, values, and character. The brain, constantly recording patterns of action and consequence, gradually integrates repeated behaviors into the architecture of identity. What begins as intentional effort eventually becomes part of a person's intrinsic character, subtly shaping how they perceive themselves and how others perceive them. Habits, in this way, serve as both mirror and sculptor, reflecting existing traits while simultaneously molding new dimensions of personality. The connection between habit and identity arises from the brain's remarkable capacity for reinforcement. Each repeated behavior strengthens neural pathways, embedding the action deeply within memory and motor systems. Over time, the brain begins to anticipate the behavior automatically, requiring less conscious effort. When actions are repeated consistently, they form patterns that influence not only behavior but self-conception. A person who exercises regularly internalizes the idea of being active. A person who writes daily begins to see themselves as creative or disciplined. The repetition of action communicates a message to the mind: this is who I am. Habits become symbolic of identity, translating behavior into personal meaning. Beyond internal self-perception, habits also influence social identity. Humans are inherently social, and consistent behaviors signal traits to others. Reliability, diligence, kindness, or generosity are not declared but observed through repeated action. Colleagues notice someone who consistently meets deadlines. Friends recognize a person who listens attentively. Family members rely on a member who regularly contributes to household responsibilities. Habits communicate character, reinforcing social bonds and shaping external perception. Over time, the alignment between internal and external identity strengthens, creating a coherent sense of self anchored in action. Habits also play a crucial role in the development of moral and ethical character. Daily choices, even small ones, accumulate to define patterns of behavior that express values. Choosing honesty over convenience, patience over frustration, or generosity over selfishness may seem inconsequential in isolation, but when repeated, these actions form enduring aspects of moral character. The brain, responsive to both reward and consequence, reinforces behaviors aligned with long-term goals and values. Habits, therefore, are not neutral. They are moral instruments, shaping not only practical routines, but the ethical contours of personality. The influence of habits on identity is reciprocal. As behaviors are repeated, they strengthen traits associated with self-perception, which in turn encourage further repetition. A person who identifies as organized is more likely to maintain orderly habits, reinforcing the trait. Someone who sees themselves as compassionate is more likely to engage in acts of kindness consistently. This feedback loop between action and self-conception highlights the power of habits to shape not only external behavior, but the internal framework through which individuals interpret themselves and their lives. Long-term habits can also create resilience and stability in identity. When life circumstances fluctuate, well-established behaviors provide continuity, anchoring a sense of self even amid change. Morning routines, professional practices, creative disciplines, or physical training Habits contribute to a stable structure that persists despite stress, fatigue, or external disruption. These consistent actions act as reference points, reinforcing identity and character even when the broader environment is uncertain. Habits become both the foundation and the compass of personal development, offering direction and coherence in an otherwise unpredictable world. Habits also influence aspiration and growth. The repeated pursuit of improvement, learning, or mastery gradually transforms abilities into core aspects of self-perception. A musician practicing daily, a student dedicating time to study, or an athlete committing to training internalizes these repeated actions as expressions of capability and potential. Over time, identity evolves in alignment with these practices, reinforcing motivation, resilience, and personal ambition. Habits become pathways not only to skill but to self-realization, connecting effort with long-term personal meaning. Even minor behaviors contribute to the tapestry of identity. Small daily actions, how one greets others, how consistently one follows through on commitments, or how one manages time, gradually form patterns that define character. While individually subtle, their cumulative effect is profound. The brain integrates these repeated behaviors, encoding them as part of the self. Habits are therefore more than routines. They are narrative threads that, woven together over time, create the story of who a person is. In conclusion, habits are central architects of identity and character. Through repetition, they transform conscious effort into automatic patterns, which shape self-perception, social perception, moral integrity, and personal growth. What begins as intentional practice evolves into instinctive action, embedding traits, values, and personality within the very neural structure of the brain. Over time, habits do more than structure daily life, they define it, silently molding the individual from the inside out. They illustrate the profound truth that who we are is not only shaped by our intentions, but by the consistent actions we perform day after day, moment after moment.